Okay, so first off, we have our left to right shifter circuit. In this case, we have four data bits right here, and then we have our left and right input selector, or left to right input, and then we have our shift output and our four data bit outputs right here. And in this case, what this circuit needs function is to shift either one bit to the left or one bit to the right. So right here we have a more simplified circuit schematic for the shift left and right. Right here we still have our shift output, our four data bit outputs, and our four data bit inputs in our left and right selector. But as you can see right here, L0 means that if it's L or if it's at a low on this input, that means it's shifting left. And if it's at a high, then that means it's shifting right. So right here we have a more simplified schematic of the circuit. In this case, I used a bigger wire to connect all four data inputs, and then as well as the outputs. And so let's say we have a that's better. We have a 1100. Right now it's shifted to the left one data bit, as you can see right here. And if we were to turn it on, shifts it to the right data bit. But let's say we just have one right here, 0100. We go ahead and turn it on. You can see that it shifts it to the right one data bit. So that's basically the function of this shifter circuit. See, it shifts it to the right. And next up, we have our shifter four modes. So this is a little more complex circuit. In this case, instead of using mux 2 to 1s like we used in the shifter left and right circuit right here, we are using four mux 4 to 1. And in order to create the circuit, I needed to use 5 of them in total. And in this case, we also have 4 data bit inputs, 4 data bit outputs, 1 shifter output. But what changes in this circuit is that we now have 2 selector inputs that will help either produce no change, which is going to be 01. Well, first off, it's 00, which should produce shift left. 01, a no change. 10 is a shift right, a logical shift right. And 11 is a shift right arithmetic. And so if we were to, and these mux 4 to 1, were created in the previous video C5, where we created the mux 2 to 1, mux 4 to 1, and mux 8 to 1. And so this is a more simplified example or version of the circuit. I used bigger wires to connect all four data bits, single right here, as well as the outputs. And right here we have the selectors and the shifter outputs. So right now, if we were to put, let's say 1 1 0 0, you can see it's a shift left, and if we were to put a 0 1, it's no change. And if we were to do 1 0, should be, yeah, so it should be a right shift logical. And then 1 1 is a shift right arithmetic. So let's try just one. So this is shift right. Change and shift right arithmetic. And so the difference between the a logical and an arithmetic shift is that in this case it's just the right logical and arithmetic shift. So um, a right logical shift moves each bit to the right by 1. The least significant bit is taken off, and the empty space, the most significant bit, is filled with a 0. And then the arithmetic shift, one position moves each bit to the right by 1, and the least significant bit is taken off, and the most significant bit is filled with the value of the previous most significant bit. And this is achieved in the wiring because, as you can see right here, there's one connected to the selector 1, wires connected to selector 1, and then selector 0. And then there's the D input is connected to the A2 input, but it's also connected to the D2. So this allows it to either produce a logical or an arithmetic output for the shift rights. And as you can see, like I said before, in both shifter circuits, the shift left and right circuit and the shift four modes, we needed to use the muxes in order to create a circuit such as this one. So I had to use it as a building block in order to produce the outputs that I'm getting right now, which is the shift left, no change, shift right logical, shift right arithmetic. And without the use of muxes, it would take a lot more time and a lot more wiring and a lot more space. And the complexity of it would increase more than the circuit that we have right here, due to the fact that there would be a lot more AND gates, because there is this is an example of mux 4 to 1. So imagine this but multiplied by 5. So it would get a lot messier than how this looks. But yeah, so this is the shifter 4 or shifter 4 modes, which allows the output of 4 different answers. And then this one allows for basically two different modes, which could produce a lot of different outputs, which I meant to say for this as well. So it could produce an immense variety of different outputs, which but it differs depending on the mode that is being used, such as either shift left, there's no change, there's shift right logical, and then there's shift right arithmetic. That's all for this video. Thank you.